4.1, graph quadratic functions in standard form. You should have your notes done for this. So examples, they say to copy and complete the table of values for the function. So for number 4, we're given the function y equals negative 3x squared. And then we have x and y values. We're given x, we have to find y. So negative 2, negative 1, 0, 1, and 2. So then we're just going to plug in each value for x and figure out what y is equal to solve for this. So if you plug in negative 2 squared is
4
times negative 3.
negative 12.
Negative 12. Negative 1 squared
1
times negative 3.
negative 3.
Plug in 0. You have negative 3 times 0, which is
0.
plug in 1.
And
Yep. And 2.
Negative 12.
Negative 12. So notice, regardless of what the sign is, with one like this, they're going to be the same spread. So like whatever this one was, this one's also going to be, as long as the numbers match up at the top. All right, so let's get into some that are actually graphing. So it says to graph the function and compare the graph with the graph of y equals x squared. So we're just graphing it. We're not doing all the extra stuff. Number 8, y equals 5x squared. So we need to first find our axis of symmetry. So our axis of symmetry is at x equals minus b over 2a. In this situation, we don't have a b value because b would be the next term that's just got an x on it, but there's not one. So we would just have x equals 0 since we don't have the term. We would just say that this is like plus 0, x plus 0 in terms of the letters that go there. And then the vertex, we want to know what happens when x equals 0 because your vertex is always going to be on your axis of symmetry. So we plug in 0 for x in this case. So 5 times 0 squared is 0. So then your vertex is at 0, 0. So when we graph it, so our axis of symmetry is always going to be drawn as a dotted line at whatever the x value is. So this one's at x equals 0. So I'm just going to extend with a dotted line my y-axis since it's at x equals 0. Your vertex is at 0, 0, so we draw a point. Now these are graphing parabolas. If it is negative out front, it opens down. If it's positive, it opens up. Okay, so this one's positive, so it's going to open up. I can pick any other value on the x-axis and plug that in and see what happens. So I'm going to do 1 because that's the easiest. So when x equals 1, we would do 5 times 1 squared, which is equal to 5. So we have a point at 1, 5. So 1, we go up 1, 2, 3, 4, 5. Now symmetry means whatever happens on one side, we can do on the other. or matches on the other. So if we have an axis of symmetry, that means if we have a point a certain distance away on the right side, it's also the same distance away on the left. So we would get a -1, 5, input a dot, and then round it off. This is rounded. If you do it like this, that's absolute value, and that's not right. So it's got to be rounded like a U. I'm just going to make a note here since it's harder to see this one, that it's the axis of symmetry. Let's look at a -1. Number 10, we have y equals -x squared. So if this is negative, it opens up or down? Down. So I'm going to go ahead and note opens down. So that way when I graph it, a lot of people will know, oh, it opens down, and then they'll draw me a graph that opens up. So that way you can go back and check, okay, so it's open down, my graph opens down, I'm good. So my axis of symmetry, there's no b value again, so it's just going to be at x equals 0. Okay, in a minute we'll have some that actually have a b value, so we can actually do something. So my vertex would be where then?
0, 0.
My vertex is going to be at 0, 0. So I can get ready to graph it. All right, so my axis of symmetry is at x equals 0. So again, I'm just going to extend my y-axis here. My vertex is at 0, 0. And then I'm going to do the same thing like I did in the last one. I'm going to pick a point. I always like to do, if 0 is an option, because when things start getting like shifted around, if 0 is an option, I'll use 0. But if not, I try to use something that's 1 away from my axis of symmetry. So I'm going to use 1. So if I plug in 1, I have negative, parentheses, 1 squared. So what does that equal to? -1. So when x equals 1, y equals -1. Since I have my axis of symmetry, I can do the same thing to the left side. And then I just draw my parabola opening down. Alright, now we'll get into the ones that actually start to move around a little bit, where you can actually see what's happening. So number 14, we have y equals 4x squared plus 1. So notice I still don't have a b term because I don't have the plus bx term, but I do have the c term at the end. Okay, so this is a and this is c for the purposes of filling in stuff and solving. So my axis of symmetry is minus b over 2a, so c doesn't change anything. I don't have a b term, so my axis of symmetry is at x is equal to 0. But now when I go to do the vertex, I plug in x to this and I solve. Okay, I plug in 0 for x. So when I do my vertex, I now have 4 times 0 squared plus 1. So the 4 times 0, that's going to go away, but I'm still left with 1. So now my vertex is at 0, 1. So I'm going to set up my graph. And is this one opening up or down? It's going to open up, so my axis of symmetry, since it's at x equals 0, we're just going to extend again. And you do have to graph the axis of symmetry for it to be completely right when you're graphing. I am going to be checking for that. So our vertex is at 0, 1. So 0 and 1. So then I'm going to do plug in 1. So 4 times 1 squared plus 1 is equal to what? 5. So at 1, I go up to 5. And then with the axis of symmetry, I do the same thing to the left. So at -1, I go up to 5. And then we just graph it.
Do we only put like the dotted lines and then axis of symmetry when x is 0?
No, so we're getting ready to do one that's going to have it not be 0. Yeah, it won't be 0. So you'll have to draw the entire thing dotted. I just don't, there's just not a point in going over top of and being like, you know, over top of it. I mean, you can, but it's going to be hard to see anyways. If you want to use another color to draw your axis of symmetry, that's fine. Some people like to do that just to mix it up a little bit. All right, so now one that has a b value. So we have, well, y equals 3x squared minus 6x plus 4. So is this one going to open up or down? Opens up, because the 3x squared, that's positive. So I need to find my axis of symmetry, but now I have a b value, so I've actually got to do a little bit of work. So it's minus b over 2a is how we find it. And the signs are important. So we have -6 is b. So we have -6 over 2 times a is 3. So the two negatives cancel and become positive. So then I have 6 over 2 times 3 is 6. So that's going to be 1. So my axis of symmetry is at x equals 1. For the vertex, I plug in 1, so y equals, so I have 3 times 1 squared minus 6 times 1 plus 4. So 1 squared is just 1 times 3 is 3. -6 times 1 is -6 plus 4. So that's going to end up being 1. So my vertex then is at 1, 1. And I can set up my graph now. So my axis of symmetry we said is at x equals 1, so we're going to go to 1 and we're going to draw a dotted line on the whole thing. All right, and then we're going to put our vertex on, so at 1, 1, so goes there. Now, it's not on the y-axis anymore, so now I have the option of using 0. Okay, so I'm going to plug in 0, so y equals 3 times 0 squared minus 6 times 0 plus 4. What does that give you? 4. So at 0, I go up to 4. That's 1 away from my axis of symmetry on the left, so if I go 1 away on the right, I have a point there as well. And when they're really tight like this, sometimes it will kind of look like a V, so just do your best to round off the bottom as much as possible. Do you have any questions so far? We're going to do more. I just wanted to pause now that we've had one that actually has a little bit of work to do to it to see if we anything. All right. 24. So I've got y equals negative 2x squared minus 6x plus 3. So are we going to open up or down? Opens down. All right, so axis of symmetry. We're at minus b over 2a, so that's going to be minus negative 6 over 2 times a is negative 2. So now I've got positive 6 over negative 4, so that's equal to what?
Negative 3 halves.
Negative 3 halves. So x equals negative 3 halves is your axis of symmetry. Overall, I really do try to not give you ones with fractions, especially on a test or a quiz, just because they're so, weird. But honestly, some of the problems, it's just the only way that they have them. More of them will have fractions than won't, so I try to not give really, really weird ones if I can help it. So your vertex, then we have to plug that point in, which is why it gets annoying. If you want to treat it as 1.5 instead of 3 halves, you are more than welcome to do that. In this case, it'll actually help cancel some stuff if you leave it, but it's up to you. So we have negative 2 times negative 3 halves squared minus 6 times negative 3 halves plus 3. What?
The fraction.
Yeah. So we have negative 2 times, so squaring negative 3 halves, the negative goes away. 3 squared is 9 over 2 squared is 4. Then I'm going to go ahead and cancel as much of this as I can. So negative times negative is going to be positive. The 2 here cancels with the 6 to give you a 1 on the bottom and a 3 there. So that's going to be plus 9 plus 3. Then the 2 and the 4 can cancel. Leaves you with a 2 on the bottom. So at this point, if you want to change and write it as a decimal now, that's also fine. This is the one section where I will give you the whatever you want to do. If you want to do a mixed number, you want to do a fraction, you want to do a decimal, it's whatever's easiest for you because obviously you have to graph them. So this is going to be negative. Let's see, 9 halves is what, 4.5? So negative 4.5 plus 9 plus 3. I'm doing this because I don't feel like getting a common denominator. So 9 plus 3 is 12 minus 4.5, so that's 7.5. And I probably would rewrite my axis of symmetry as negative 1.5 just for the sake of having everything either as decimals or fractions. But again, as long as you know how to You know what it means. You know how to graph it. That's fine. So my vertex is actually where? At negative 1.5 and 7.5. And we said it opens down. Let's see, no. Right over here. I don't know why I just went down so far. It's a positive 7.5. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right, so my axis of symmetry is at negative 1.5. So your graph did not need to be that long going down that way. It's obviously it'll eventually get there, but because parabolas keep going forever, but you didn't have to do it for this one. All right, so my vertex is at negative 1.5 and 7.5. 2, 3, 4, 5, 6, 7.5. So then this is one where I would plug in 0 to check it. So if I plug in 0, I have negative 2 times 0 minus 6 times 0 plus 3. So I'm left with 3. So there's a point at 0, 3. So at 0, I go up to 3. Now this doesn't exactly look like it, but it's 1.5 away on the right, so I'm going to go 1.5 away on the left. So there'll be a point at 3, 3. And then you can connect
So, like, when we're doing that, however far away it is from the axis of symmetry, like, so in there it was negative 1.5. So would that always be the x when you're, like, plugging it in? So, like, how we plugged in and found 3 for y, would we always be, I don't know if it makes sense, but like, whatever the axis of symmetry is, would we always be that far away?
like to when you're finding the other values, you can actually graph it. So so you just decide what value, but like every once in a while, you'll end up with an axis of symmetry over here at 5. Well, when you plug in 0, it's probably going to end up being some exorbitant number, like either way down here or way up here. So you're not going to want to do that. So I would always go like, my general rule is no more than 2 away from your axis of symmetry, or you're going to end up with an obnoxiously large graph.
Okay.
So, I just try to use 0, 1, or negative 1 if it's an option.
Okay.
So even if it means going a little farther away. But I mean, I can kind of look at it and say, like, the other day there was one in pre-cal we were doing like this, I think. And it had a value of like 13. Like the C value was 13. So when I went to graph it, I was like, I don't want to plug in 0 because I don't want to have to go up to 13. Like I had my graph going to like 6 or 7. So I was like, I'm going to pick a different number, like, I don't know, it might have been like negative 2. I was like, it's harder to plug in. I mean, relatively speaking, it's harder than 0. But it gave me a number much easier to work with in terms of where it was. So, and eventually we'll be graphing not in standard form. So these are standard form, but we'll do vertex form and, well, if you've done all your notes, you've seen the other forms we'll do.
The stuff you wrote in green at the bottom. Yeah. So when we're doing that, is that just like the original problem that or the original thing we were given?
Yeah, so I'm basically taking the original problem, so I'm doing it for f of 0. So if it was in function notation, I'm saying when x is equal to 0 or whatever the value is. So yeah, I'm using the original equation to plug that into.
This isn't just anything, but then wouldn't there be wouldn't it be -2 times 0 squared?
Yeah, but once I know it's a 0, I just don't. Honestly, for me, I probably wouldn't even write it if I was just doing it. I'm more so doing it so that way if you have something else that you end up plugging in, you have it to look at so that you're not like, I mean, yes, if I wanted to technically be right, I could put that there, but I'm just like, well, 0 squared is still 0, so yeah. Yeah, everything gets plugged into the original except for this formula for axis of symmetry, but everything else after that gets plugged into whatever your original equation was. All right, I'm going to give you one to try on your own. I'm going to warn you, it is weird fractions. So I'm going to apologize, but if you can do that one, you should be fine. This one, you pretty much will have no choice but to leave as a fraction, unfortunately, because it will be a repeating decimal. So I just gave them this one to try on their own so you can
When you do mixed numbers,
yeah, whatever it's, but this section it's whatever's convenient for you. All right, what did we get for our axis of symmetry?
-1/3.
Yep, and our vertex?
-1/3. -4/3. 4 1/3.
So then, what?
So I forgot how to subtract a fraction from a whole number. It's my space. Isn't it just like it would become like 4 and 3 over 3?
Yeah.
Okay. Alright, that's how I do it. Alright.
So I found the axis of symmetry using minus b over 2a, so that ended up giving me -1/3. So x equals -1/3 is my axis of symmetry. And then my vertex, I had to plug in -1/3, which, I mean, you could have done it different ways, but I would not use, well, I wouldn't have wanted to use a decimal with this one personally. Fractions are easier. So then, hold on. You had to, or you could simplify this down afterwards. I rewrote -5 as -15 over 3, so that I had a common denominator there. Then you get -13 over 3. You can either rewrite it or either write it on your vertex as -1/3 and -13 over 3, or for the purposes of the fact that you're going to have to graph it, it's probably easier to write it as a mixed number, or at that point to translate it to a decimal. It's easier to work with then. So I had an axis of symmetry at -1/3, so it's really, really close here, obviously. I chose then to use 0. I'm only a third away, obviously, so it shouldn't be anything too crazy. So when you go to write your second point, it makes it a little bit, it's hard to squeeze it in, but it's the principle of how it looks more than anything. So we plug in, I plugged in 0, so everything canceled, leaving me with -5. So at 0, -5, and then I went 1/3, well, ballpark 1/3 away on the left side. It's obviously really tight. I could have maybe expanded my graph a little bit to make it fit a little bit better, or I could have chosen a different number altogether. But anyway, so your graph goes down like that and it opens down. Now what's your question?
You put your vertex at -1/3, -3 and 1/3.
Okay, well, regardless, it's moving down one, but yes. Okay, anyways, any questions? Any more questions? You ready to try some for homework? And if we need to go over them tomorrow, we can. Keep looking up there, and that clock is very wrong, so. All right, so your problems are 3, 7, 13, and 25. And then if you feel like because I've tried to give you a variety here, if you feel like you're still struggling or you need to do some optional extra practice, I would say do 11, 21, and 23. But that's purely up to you. You have to do the top 4 and then submit them.